Hey guys, welcome back to another episode of Absolute Astronomy, the podcast where we discuss space things because space is cool, so let's talk about it. Today we're continuing our dissection of the solar system and talking about the planet named after the goddess of love and beauty. But before we get to that, let's start things off with a twist.
3, 2, 1.
Welcome to This Week in Space Talk, where we discuss what's making headlines in the space community. So, something big just happened that's going to go down in astronomy history. I'm talking like Nobel Peace Prize worthy big. We can now hear the universe. This breakthrough was discovered by the scientists of the LIGO Science Collaboration, which stands for Laser Interferometer Gravitational Wave Observatory. Try saying that 5 times fast. Gravitational waves are formed when massive objects accelerate, collide, or explode. The gravitational wave spectrum can reveal the dark universe, including where black holes collide. On September 14, 2015, LIGO's newly upgraded system was able to detect a rather large eruption. Approximately 1.3 billion light-years away, 2 black holes became trapped in their mutual gravitational well and started to orbit one another. Before merging, the holes were 29 and 36 times the mass of our Sun. Very quickly, the 2 rapidly spinning objects touched and unleashed a giant fury of energy, which caused it to lose 3 times the mass of our Sun. Then 1.3 billion light-years later, these waves reached the Earth. Theory suggests that when 2 black holes merge together, the gravitational wave signal should produce a very fast pulse, which would be represented as a chirp if slowed down. Here's what it sounds like. What you just heard were 2 black holes spiraling into one another and merging. This event is believed to occur somewhere in the universe once every 15 minutes. By the end of this podcast, another one will have happened somewhere. Another cool thing about the signal is that we know the general direction of which it came. The Livingston station in Louisiana heard the chirp 7 milliseconds before the Hanford station in Washington, meaning that the signal came from the southern hemisphere skies. Coming up, we'll be taking a look at the second planet in line in our solar system, but first enjoy this track by Uppermost on Absolute Astronomy. Welcome back. That was Beautiful Light by Uppermost. Let's dive into our specialty space topic of the day, the hot, hellish, and volcanic planet Venus. Named after the Roman goddess of love and beauty, Venus is the second closest planet to our sun. It's actually the only planet in our solar system to be named after a female. It rotates on an axis opposite to most planets, making the sun rise in the west and set in the east. It takes 225 days to orbit the sun, but 243 for the planet to complete a full rotation on its axis. So a day is longer than a year. Weird. Venus and Earth are often called twins because of their similarities in size, mass, density, composition, and gravity. But unfortunately, that's where the list of common factors end. Venus is the hottest planet in our solar system, and this is due to its large greenhouse effect. You've probably heard scientists refer to this term when talking about global warming on our planet, but Venus can reach up to 465 degrees Celsius. All probes that have been sent to the planet in the past have only lasted a few hours before melting away. Venus's atmosphere is quite deadly too. It consists mainly of carbon dioxide and clouds of sulfuric acid. Scientists have detected some water in the atmosphere, but there's not a whole lot there. The pressure of the planet is 90 times that of Earth, and the surface is extremely dry. During its evolution, ultraviolet rays from the sun evaporated water quickly, keeping the planet in a prolonged molten state. And for obvious reasons, despite finding trace of water in the atmosphere, there's no actual liquid water on the planet due to the scorching heat. Venus's surface is relatively smooth with volcanoes spread throughout, some of which are still active. There are 6 mountain ranges on the planet, with the mountain range Maxwell being the highest at 11.3 kilometers tall. That might not sound like much, but do you really want to question a planet that could literally burn you alive? I didn't think so. Let's talk more about Venus's insane climate. In 2005, the European Space Agency discovered that the lightning storms on the planet were associated with clouds of sulfuric acid compared to other planets where they're associated with water. So what does this mean? Crazy electrical charges firing down from the sky. These bursts of sulfuric lightning break up molecules into fragments and then recombine them with other fragments from different materials, resulting in one freaky science experiment. Venus also has a cyclone that remains in constant flux. First observed in 2006, a cyclone was found to be constantly breaking apart and reforming, and it's still going to this day. Have fun trying to outrun that thing if it's in your path. Venus also has strange stripes in its upper clouds, which are dubbed as the blue or ultraviolet absorbers because they absorb blue and ultraviolet wavelengths. They're soaking up a ton of energy, close to half of the total solar energy that the planet absorbs. Scientists still don't know their full purpose, but they definitely play a key role in keeping the planet a living, breathing hell. Alright, let's take a break from all the crazy stuff and talk about something cool, the transit of Venus. This is an event in which the planet passes directly between the sun and a superior planet. From Earth, it looks like a little black dot is flying across the face of the sun. In fact, it's kind of similar to a solar eclipse caused by the moon. However, because Venus is much farther away from us, the planet appears smaller and travels more slowly. The first scientific observation of the event dates back to 1639 when Jeremiah Horrocks was able to see it happening from his home in England. Johannes Kepler was the one who predicted the event, saying that the transits would occur in 1631 and 1761. Unfortunately, he died in 1630, so Jeremiah was the first to actually see the event. Transits of Venus are among the rarest of predictable astronomical phenomena. They typically occur in patterns that repeat every 243 years, with pairs of transits 8 years apart, separated by long gaps of 121 and 105 years. Whew, those are a lot of numbers. So why are events like this so rare? The transit of Venus doesn't occur every year simply because the orbits of Venus and Earth are slightly out of alignment. Typically when we see Venus, it's either early in the morning or late at night, and appears just a little above or a little below the sun. It takes approximately 243 years for the two planets to line up in the exact same orbital plane in relation to the sun. The last transit of Venus was on the 5th and 6th of June 2012, and the next pair is expected in December 2117 and December 2125. So remember kids, eat your vegetables, stay in school, and you might just be around to see this event. So yeah, Earth and Venus are pretty much twins, except Venus is the batshit crazy sibling. I mean, we're a little messed up too, but at least we don't have molecule-breaking sulfuric acid lightning storms, am I right? Welcome back. That was Maliblue by Darius. And unfortunately, we've come to the end of yet another episode. Thank you guys so much for listening, and be sure to follow me on Twitter at astro_podcast for news stories, updates, and cool space photos of the day. Also, be sure to check out the YouTube channel. I'll be posting some content soon. The link is down in the description. And as always, if you have a topic you'd like me to discuss, feel free to send me a message. And before I sign off, I'd like to just show you guys another little blooper that I had from earlier where I messed up a sentence and couldn't stop laughing because I'm 5 years old. Enjoy. Very quickly, the two rapidly spinning objects touched each other and... God, I'm so immature. Very quickly, the two rapidly spinning on... How old am I? 5? Damn it, I can't say it. Very quickly, the two rapidly spinning objects. Oh.